start to record. So we will use these tables again and again. And in the case if you don't have the link to these tables, I'm gonna paste this link here in the Zoom chat. Yes, please. It's a very good idea to discuss whatever you have in mind. So we will have a little quiz at the end of class, and then after the quiz, we can definitely talk about whatever you need to discuss with me. So it looks like we have the tables here, and we see how we use them. We see where the row and the columns meet. So let me go back to the textbook and do another problem to refresh your memories on how to use tables. So how about exercise number 26? There's one more problem. So now they want again the area to be less than negative 361. Okay, so Z is smaller than negative 3.61. So first of all, I write it down. Then I need to find that number negative 361 in my tables. So it'd be somewhere to the left from 0, right? So negative 361. And when I open the tables, I notice that there is no negative 361 in it. What they have is the largest negative number, negative 3.5, but it's not only negative 3.5, it could also be lower. So, in other words, if I look at the number that they tell me for the area, it's a 0.0001, and this 0.0001 turns out is going to be the area for all possible values of Z to the left from minus 3.5. So you can imagine yourself, let's say minus 3.5. And since the area to the left from it is 0.0001, then they say just treat all of the areas with this number. Of course, they will be lower, but they're not really something that we have. Oh, I sent only to one person this table, so let me send it to everyone. So those are tables, that's a link, so please save it if you don't have it available, and we will use it a lot. So point is that sometimes you don't have the answer in the tables, but it's not a big deal because there is an answer. It's a 1/10,000th. So it's very, very small probability. Well, it turns out that in this section, there are some more exercises of so-called backward type. They also work with tables, but if we used Z-score to find areas, then such an exercise as number 37 is actually giving you the area instead. So in exercise 37, they again deal with that standard normal distribution, and they tell, how about if your area is 90%, what is the Z-score that would cut that area out for us? You see, instead of giving us Z-score, they want us to find the Z-score. So what they actually provide us with here, they give us the area to the left from that Z. So if I scroll to the next page of these tables, because it looks like that my Z-score here is positive, right? Because it's way larger than 0, so it has to be positive. So in the tables, they want me to find a number which is 0.9, or actually the closest to it. So if I start on the top and keep going down, I see 0.5, 0.6, 0.7. So then I get the row with 0.9. So it looks like I need to be in the previous row where the 0.9 appears first time, right? And I can see the numbers that should surround this 0.9. So please notice that if I consider the interval from 0.8997 to 0.9015, then 0.9 should sit somewhere on this interval, and it's actually could be treated as 0.9000, so it would be consistent with these little numbers. So notice that 8997 is 3 steps away from 9,000, right? 89, 97, 98, 99, and then 9,000. But to get to 9,015, I need to make 15 steps, right? Because it's 9,000, but also 15. So that's much farther to the other side than 8997. And that's the reason why we take 8997, and that number will give us a Z-score. So we always select the closest to our number. So the closest to our number in this case corresponds to the Z-score, which is 1208. So 128 is the answer for this exercise. So instead of using the Z-scores and then finding the area, we went backwards. We found area first, and then based on that area, I added the row and the column and produced the answer. So sometimes we can use tables in a backward format. I guess I'll do another exercise here so you see this again. So let me do problem number 40 that talks about 3%. So 3% is a little number like 0.03, right? 3%, that's in terms of hundreds, 0.03. So they say that 3% of thermometers rejected because some of them are too high, and another 3% rejected because some of the readings are too low. So it looks like too high will be here on the right side, and too low will be on the left side. And since the 0 is in the middle and the picture is symmetric, then I can just find the one on the left side, and on the other side it will be opposite. So if that's a Z with a plus sign on the right, then same, but negative will be on the left. So I need to find 0.03 in my tables. And for that matter, I'm gonna scroll up where the negative Z scores are located, because looks like we now need the one on the left, which is negative, right? So let us maybe clean this mess a little bit and try to find the closest number to 0.03. And to find it, again, I start on the top and move down, and I see that these will keep on increasing. And it looks like the row here with minus 0.5 or something should be the one that I use. You see in that row with minus 0.5, we start to get this 0.3, but which number is closest to it? Well, looks like, again, we found the interval, and we need to see which one of these two numbers is closer to 0.3. Is that with 15 or 81? So turns out that if I try to get to the, let's say, 3015, then I go by 15 of those units. But if that's 2981, from 81 to get to 3000, I need to get 19. Do you see? Of course, there's 0.00, but roughly speaking, the one on the left is bigger, right? That 15 actually is closer to what I need. And because of this, I need to have a column under 0.02. So my z-score is minus 0.52. So I just put together 0.5 and 0.02 and get minus 52. And on the other side, it'd be then plus 0.52. So we just use tables backwards. We will have problems in the later sections that we'll use. So why is that such a number? And the answer is because I did it wrong, because I wasn't careful. Shame on me, because I wasn't careful at all, but thanks so much for helping me, because I definitely was not careful, so I better get this concentration back. So let me clear this, but I guess you got the main point, right? We need to get closer. And in fact, I think it's good that I wasn't careful, because I actually have to go to 0.03, not to 0.3, right? Because I went to 0.3, but I went to 0.03 again, because I made a mistake. I need to be careful. I need to concentrate. So I need to say to myself, let's concentrate. So now I'm concentrated, and I got to 0.03, and looks like once I hit that row, please notice 0.04 is after it, right? So I need to be in the row with 0.03, so it's next to minus 1.8. So let's see, I keep going to the right, and here's the position. Here it is, finally. But again, thank you so much for being careful and making sure that we do it right. So maybe I can still use that same picture. I'm just gonna get rid of that part. And did you see which number was closer? Is that 301 or 0294? Looks like this is 0.0301, right? And on the other side is 0.0294. So yes, little mistake, little moment where you relaxed and didn't pay attention. Yeah, the whole thing may be wrong. So it is definitely a very good idea to always double check, especially when you're taking a test or a quiz. Remember, I always give you plenty of time so you can double check your answer. Don't hurry to try to be first and to leave the Zoom meeting. Make sure you double check, because anyone can make a little mistake. So you don't want to select the wrong answers. You want to get the right answer. So it looks like 0.03 is somewhere in this interval in between of these two numbers, and definitely 0301 is closer, right? So this first number, because the other one is you need 0.006 to get there. So the column is under 0.08, So we are minus 1.88, right? That's quite different with what I've produced, right? So it is definitely important to pay attention. So minus 188 on the other side is plus 188. So finally, we're done. Anyways, I want to move on to the next section because it looks like we're pretty much done with this one. So I'm going to show you how we can utilize these tables to find probabilities just about for any possible normal distribution. So we used to work with a rare case where your mean was equal to 0 and a standard deviation was equal to 1. And of course, for mean and for the standard deviation, there could be just about any values. And that's exactly what they have here in the next section. So they're talking about how we can convert any normal distribution to our special one, to the standard normal. So to convert, here's the formula. So to convert, I can find that z-square based on any value of x, I can find the any value, a corresponding value of z, and this is x subtract mean over standard deviation. So let me take a problem, and based on that exercise, I'm sure you will get a little bit of intuition why we should be using this type of conversion formula. So problem 1, I think, is a good example and intuitive. So let me check what's going on in problem 1. That says, if they want you to find the probability is less than 1/15. So they say probability less than 1/15. Please notice I no longer put z in the parentheses. The reason is that we have just distribution with mean equal to 100 and a standard deviation equals to 15. So I just have some normal distribution. So 100 is here. That's where the highest probability is, the mean. And standard deviation is equal to 15. So their equation is find area or probability that corresponds to 115 or lower values. And it turns out that what we can do is use the formula above to get that corresponding value of z that will give us exactly the same area. And that same area I can find using tables as long as I get my z. So to get z, I will use this new formula. So let me use it first, and then we'll see why it makes sense based on these numbers. So for value of x, I have 115. So that's the one that I want to convert to the z-score. Mean is given, it's 100. And then standard deviation is 15. So when I subtract 115 and 100, I get 15, and I divide it by 15, and I get 1. So the z-score that corresponds to this particular question equals to 1. And please notice that since your standard deviation is 15, that's exactly 1 z-score from my mean, from my center. And that's exactly what z-score formula says. How many standard deviations we are away from mean. So I guess that's the idea of z-score, but you don't have to remember this. You could just use this formula anytime you convert. And then, well, let's use the tables carefully. So I need to find a z-score which is positive. So I need to scroll down where the positives are. So I need 1.0, right? Because my z-score happens to be 1, or you can say it's a 1.00. So 0 will be for the row, and actually for the row will be 1.0, and for the column will be 0.00, right? So this is my area. It came from the tables. It is equal to 0.8413, and this is exactly what we need, because they want an area from z to the left, or from the left to z, so that's exactly what the tables gave us. So it's about 84%. So what I just did, I answered the question. So there is some distribution, and they know it's mean and standard deviation. So they say population of people is distributed normally with such a mean and such a standard deviation. Okay, so the question is, so what's the chance that someone has the score less than 115? So we found 84%. How about that? So let's say we want to find the group of people with higher scores for whatever reason. Well, the chances will be less than that for sure, because 84% chance that it's lower. So it is very interesting. And I guess that's what we are going to do in this section. So let me try problem number 9 to see that this is having tremendous applications to the real life. And that's what statistics is all about. So some people get very impressed. So for instance, let's say if you're working in the hospital and measuring people's temperature, or just collect information about these, then here's the information. They say that at the hospital in New York, they use mean, which is 98.2. So in exercise 9, let me start right away with my favorite bell-shaped curve, right? So the mean, the maximum will be at 98.2, and that's going to be a mu, right? And standard deviation, they say, is a sigma, and this is 0.62 degrees. Okay, so we have mean, we have standard deviation. Let me write this a little bit better. So now we need to answer question in part A that says 100.6 is the lowest temperature considered to be a fever. So the question is, what percentage, what probability, P, percent, probability, the same thing, that people will have more, so X is higher than or equal to 100.6. So in other words, what part of population will have a fever? Because fever is when you have a high temperature, right? So it could be cut off 100.6 or higher. So the question is, what will be corresponding z-score to this, right? So if I be able to find that z, then I should be able to get the area, and that area is exactly that percentage. So it's time to use this new formula. Again, this is x subtract mean divided by standard deviation, right? So let me put the numbers in. Just same as in the previous example. So I put this x value, the number x is compared with 100.6 minus 98.2, that's the mean for population, and then divide this by 0.62. And you can definitely, you need to use a calculator here. So make sure you use parentheses around numerator. So you're going to do this right. So I'm going to enter in the parentheses my 100. So try to put this in a calculator. In fact, I think it'd be a good idea if I ask you to calculate one z-score like that for a quiz. So you get used to this calculator numbers. And then 0.62 I put in denominator. And there you go. I have the z-score. 3 and a little something. 3.870, whatever. Dot. We usually need only hundreds, right? So this looks like 3.87. So now the question is, what is the probability? Well, let us check the table. Do we see such a big z-score in it, in the tables? I don't think so. It goes up to 3.5, but that's fine. We know how to get the answer. If it's 3.5 and up, then it's 0.9999. And that's the area from the left side, right? Remember, we always get area from the left, right? Well, it's okay. We need area on the other side. That's what we need. So take its complement, remember? Subtract from 1, our old favorite. Subtract from 1, so you get the other side. So I subtract this bunch of 9s from 1, I get 0, 0, 0, 1. That's the little probability. So it looks like no chance that a person will have a fever, pretty much. Not too many people have fever, so looks like it's normal. So it looks like we have a z-score calculated. And how about if I ask you to calculate z-score for a little quiz? So please find z that correspond to x is equal to 100. So I give you a nicer number, 100. I think it's better than 100 and something, right? So what you should do is get the calculator so you can see what I just did here. And the calculator, where's my calculator? Here it is. So you need to calculate the z-score. Exactly the same thing that I just produced for the exercise. So I use this formula, right, to find a z-score, and I plugged in 100.6 and some other stuff. So it looks like the only thing that you're going to change is 100.6. So I want you to practice to use your calculator carefully without a hurry. So please do that. And please put your answer here in the Zoom chat. And I'm going to stop recording.